What if you could divide by numbers like 9, 11, or 5 in your head, faster than someone tapping a calculator? In this lesson, you'll uncover number patterns that turn division into quick, clever code cracking moves. Every number has a kind of secret code called its digit sum. You find it by adding the digits again and again until just one digit is left. So 4, 7, and 2 make 13, then 1 and 3 make 4. That final digit is like the number's fingerprint. Digit sums aren't just fun, they're useful. They power a shortcut called checking with nines, which helps you spot wrong answers without redoing the whole calculation. Turn each number in your question and your answer into a single digit by adding its digits repeatedly. If the two digit sums match, your answer is probably correct. Let's see this digit sum check in action. Imagine your friend says 23 times 4 is 92. First, digit sum 23. 2 plus 3 gives 5. Multiply that 5 by 4 to get 20, then 2. Now digit sum 92. 9 plus 2 gives 11. Then 1 plus 1 gives 2. Both sides give 2. So 92 is probably correct. 9 has a special pattern. If you add a number's digits and the total is 9, that number is exactly divisible by 9. For example, 135 works because 1 plus 3 plus 5 equals 9. After dividing by 9, you can check your result by multiplying back and quickly comparing digit sums. Now use 9's pattern as a shortcut for division with a running sum. Take 728 divided by 9. First, just bring the 7 straight down. Next, add 7 and 2 to get 9. That's your next digit. Now add 9 and 8 to get 17. That's too big for one digit. So ask, how many 9's fit in 17? 1 9, remainder 8. So 728 divided by 9 becomes 80, remainder 8. 11 has its own quick divisibility test you can do in your head. Label the digits from the right as first, second, third, and so on. Add the digits in the odd places. Add the digits in the even places. Then subtract one total from the other. If that difference is exactly 0 or 11, your number is divisible by 11. When you divide by 11 in your head, don't attack the whole number at once. Look for friendly facts. For 330, ignore the 0. 33 divided by 11 is 3. So 330 divided by 11 is 30. For 253, think 11 times 20 is 220, which leaves 33, and 33 is 3 elevens. So 253 divided by 11 is 23. Some numbers are friendly because they connect closely to 10 and 100. 4 times 5. Think divide by 10, then double. So 260 times 5 becomes 26, then 52. 4 times 25. Divide by 100, then multiply by 4. 800 becomes 8, then jumps to 32. 4 times 8. Use halves, half, half, and half again. From 280 to 140 to 70 to 35. Picture yourself as the teacher with 135 stickers and 9 students. Start with a rough share. 9 times 10 is 90, so 10 each is a safe first guess. That leaves 45 stickers. Since 9 times 5 is 45, you can give 5 more to each student. So 10 plus 5 makes 15 stickers per student, found completely in your head. Now switch to money and 11s. Imagine a prize of $330 to share between 11 players. Instead of long division, zoom in on 33. If 33 divided by 11 equals 3, then 330 divided by 11 is just 10 times bigger, 30. Each player's share is $30, using the same idea, just scaled up. It's your turn to choose the fastest strategy. For numbers with 25, ask how many 25s in 100, then scale the answer up. For a divided by 5 question, divide by 10 first, then double. For division by 8, Keep halving until you're done. Pick a question, say your answer out loud, and see if you can solve all three before time runs out. When a new question appears, pause for a moment before calculating. Quickly ask, can I use a 9 trick, like digit sums? Is there an 11 pattern or a times 10 plus a bit idea? Are there 5s, 25s, or 8s so I can use 10s, hundreds, or halving? Then finish with a sanity check. Is my answer roughly the right size? You've now built a toolkit of mental maths patterns for dividing and multiplying without stress. Your mission: invent three word problems using 9, 11, or 25, and challenge a friend to solve them mentally. Patterns are your superpower. Keep spotting them everywhere you see numbers.